Hey everyone, welcome to my channel. In this session today, we'll be briefly discuss about how to become overpowered DevOps engineer. Now, what did I mean by exact that word and everything? I'll come within few minutes. But I know that it takes some bit of time for others to get notified and join. So let's just wait for another 1 or 2 minutes, okay? And then we'll quickly get started with our actual contents. Okay, then let me prepare a bit. Of course, while going through, let me know that you guys can hear me properly. All are good. Everything that you going through right now. If any issue, of course, do let me know that as well. Okay, seems like people are joining. Yeah, when joining, do let me know from where you're joining, and of course, if you have any questions, do let me know that as well. Now, let me quickly get started. Okay, so I will cut to the chase. Okay, and I know people are joining, it's all good, but I will cut to the chase and I will just quickly show you the roadmap that I've created. And it's a you can call it, it's a overly simplified roadmap. I removed a lot of other things. I know people sharing a lot of complicated one, but yes, it's easier. Okay. Okay. So look at this roadmap, okay? And of course, I will explain every bit of the things that you need to know to perform well as a DevOps engineer, and not just performing well. We're not limited to that. This is up to like what are the additional things you should be preparing also in advance. Okay, everything that you need to know about becoming a DevOps engineer and your day-to-day job you have to perform. All that will cover. Okay. Now. Hmm. So first thing that you want to learn is the Linux. Okay, and why? Because you'll be working with a lot of servers, and server run which OS. It's most of the cases it's the Linux server they use. Okay, so you should be learning Linux. That's the universal truth. Okay, no matter you're a junior DevOps engineer or senior DevOps engineer, whatever DevOps engineer you are, or maybe even the release manager, you still have to work with a Linux system. So learning Linux and working with Linux systems are absolutely necessary. There is no denial to that. Of course, in addition to that, you need to learn the shell scripting. Why? Because the repetitive tasks that you do, maybe file creation, maybe backups, maybe sending SMS or sending text using such as cron jobs, maybe connecting to other 10 systems and do update the system. All these things you can do without any repetitive tasks or manual things using the shell scripting. So, which is absolutely required for doing the automation in Linux system, that is shell scripting. Now what happens, sometimes there are complicated scenarios where you cannot just simply write a shell script. It becomes too complicated to even understand. You have to pull your hair for that. On those cases, okay, there you have the programming, and this is a high level programming. For example, Python, Java, Go, even Node.js, all this kind of stuff. So that you quickly like get grasp and quickly able to complete it. Instead of, like, for example, you have 10 resources, you have to, or 10 third party API server, you have to get the response, and you have to store the process data, and maybe based on the data you got, you have to make some conditional or business logic or perform some infrastructure update or maybe releases. All those things you can do with the help of the data mix up and match, and I'll be coming to that in a very details, don't worry. That now programming is required, now you know that, because of performing the high level automation task or maybe some internal tool development or maybe automation. All those things are there. Now virtualization and containerization. Now you know the Linux system, which is well and good, but in the cloud system, okay, or normally you cannot just keep your computer, keep it running for infinite. There will be power cut, there will be XYZ issues. I don't know, you don't know. Can be issues, maybe the internet cut off happens, right? Sometimes internet go and nothing you can do. In those cases, if you are suppose you in the old age, if you suppose you are hosting your application from your local machine, and the customer might not able to reach to your machine because of the power cut, maybe the flood, maybe whatever the reason. So that's not a practical solution, that's not a production level. Now to achieve that, you need virtualization and continuation. Now virtualization part, because most of the cloud services where you now host your applications, right, all the virtual machines, and you should be understanding how to basically create the virtual machine, how to perform updates, patching, security updates, and all this kind of basic stuff. Okay, and notice that in normal computer you have storage, in normal computer you have networking, so of course the virtual machines also have the similar components, so those also have to understand and all. Now in the modern era, it's not just the simple virtualization, we have many complicated concepts of course, but out of all this useful concept or useful methods or useful can say solution, the containerization solution is come out to be one of the winner. Okay, so basically you have your virtual machine, and in the virtual machine you are dividing the resources. For example, you have 5 GB, okay, and 5 or say 8 GB and 8 CPU. Now, if you run single application over 8 GB RAM and 8 CPU, you are wasting a lot of resources. Maybe the application doesn't need even more than one CPU, one GB memory. So the rest of that 7 GB and 7 CPU or cores, that's are underutilized. That's a loss, right? Now, with the help of this container, what you can do, you can run the container. So each container on each thread or each CPU with 1 GB memory allocation, and in the same instance itself, we can run 8 copies of the same instance, or maybe other application in the same instance, so you can achieve that with simply generalization. So that's why that is also required. Now the next step, the CI/CD. Of course, you know that if you have application, the developer will keep changing and changing, and they have to their update has to be released, maybe the staging, testing, production. We need CI/CD for that, for continuous testing and continuous delivery. Cloud. Now without cloud these days nothing happening. You will be working and you have to be working with the cloud system. So maybe AWS, Azure, GCP, and we'll come to all that within a few minutes. So you need cloud to host your application, and in the cloud there will be your, for example, instances like virtual machines, storage, networking, security, and also you have to understand all those things. Then after you have your application, say your application implemented or say hosted in those cloud service or cloud platforms, you need to maintain them, you need to patch them. Now if you have one machine you can do it manually, but what about 100,000? You cannot do that manually, right? There you have this configuration management where you can manage all this machine, all these instances, like huge scale. Okay, now we're talking about multiple instances and multiple machine, but what about creating all those resources at a scale, and you are not willing or you should not be creating all those resources manually, because it's hard to manage, hard to delete the resources, and hard to manage as well. For that you have the solution, that is infra as a code, which is a lot of other solution we'll be discussing now. Now all this roadmap, okay, I discuss. Let's go each and every point, okay, each and every point that you should know. Even Linux, there are a lot of other topics, a lot of things you should be learning, and we'll be slowly learn that after Linux is scripting, programming, virtualization, CI/CD. For each of these component, what are the things you must learn to perform as a DevOps engineer? No matter junior, mid, or senior, you have to perform all this as a say day-to-day responsibilities. So first is the Linux. So in Linux, let me just quickly. Oh, I guess. So in Linux, you have the basic Linux. Okay, of course, Linux, because Linux is a very huge thing. Okay, it's just not one or two topics. It's a combination of multiple things. Out of that, okay, out of that, I have divided in two sections. One is the basic Linux and one is the advanced Linux. Now, what are the basic Linux skills you should have as a DevOps engineer? First, I will say ls. Now, ls to list the directories, cd to change the directory, pwt to know what is the present working directory, mkdir to create the directory, rm to remove file and folders, cp to copy, mv to move, find to find folders and contents, grep to some regex and all, awkcd to for search and replace. Now, all these basic commands that you should be learning and you should be using in your day-to-day jobs. Okay, then the file system. Now, for example, if you have ever used, I mean, you normally normal people, also not at engineers, but normal people start their OS with the Microsoft Windows, right? And the moment they create Microsoft Windows, they have to create the drive, C drive, E drive, D drive, right? Similarly, just like how in Windows you used to have the folder system and all these directories, Linux also have their defined folder and directories. Okay, and now I will because I have already covered in my channel, and you will find a lot of resources. Exactly, just search about like what is the directory structure. You will see a lot of resources. Okay, so no, not I should not be repeating myself. Just know there is a file system Linux, and you need to understand the file hierarchy, the directory structure, and all that. It's very important, and to understand what is the permission level using C, and how can you change the permission level using chmod and chown. All these things should be understanding really well. Then the text editors. Now, before even discussing about this Vim Nano and why even knew the text editors. Now, uh, for example, you're working with Linux system, you may need to sometime debug the file system, or say you need to debug some file, you need to check the file, you need to modify some files and test it right there. Okay, you of course you can download the file and you can use the ftp to upload the file and then do all this execution, but that's just a lot of time taking. As an engineer, you should be more proficient, you should be more vibrant, you should be more flexible using the CLI. Okay, and this CLI tools are the top CLI tools for Linux are Vim, Nano, and Emacs, which is using which you can edit the file and file contents. Okay, there. Okay, there these things are sometimes become very obvious or very needed when you have to do some commits. You can of course do commits, say git commit then dash m, but sometimes you need to give some additional information and dash m is not enough, so you have to write, say git then commit, and then it will open maybe Vim editor, maybe Nano editor based on your preferences that you've configured, and there you have to give the commit messages. And not just limited to that, there are a lot of use cases that many configuration like nginx configuration file or apache configuration files are there, htaccess files are there. There you have to edit there and then and there and to debug what is the problem happening. So debugging and sometimes other important use cases, you should be or you will be using this text editor. So you should be understand at least one Vim or Nano, either of them, or like both of them. I will suggest you to learn it. Okay, if you are not already aware of that. Then the processes. So knowing that in Linux there are processes and threads, and whatever I'm discussing actually just as a note, I've already covered all this as a part of my DevOps and Cloud Bootcamp, which you can go to my channel live section or maybe playlist section and you can check it later on. Not now, later on. Let me just discuss all these things and go through all these things, and then definitely I will like get to your all these things. Okay. Now, this let me just quickly check. A lot of comments are coming. Okay, God. Okay, a lot of people join. It's good to see. Now, the process I was talking about, right? So in processes, there is PS command, there is stop command, htop command, and kill command. The PS command will list you the like running processes. Top command will show you the running top processes, the top resource utilizing processes. Htop, which do the similar, but the UI is a bit better. Okay, and kill. Suppose you want to kill any particular process, that you can achieve with the help of this skill. Okay, so this process management are the basic skill that you should have while you're dealing with the Linux OS. Then the networking. Now networking commands like netstat, ifconfig, sh, ping, trace route, and these are all these tools are very basic minimum things. Sometimes, most of the cases, not just sometimes, you need to debug things. Maybe your network level drivers configuration checking, or maybe connecting with other instances and all that. You need all these tools. Okay, and then the package management. Now this package management actually, I will say one of the most important part as a DevOps engineer, because you will be creating instances dynamically, you will be installing softwares on these machines dynamically, and of course while doing all that things there will be situation where your packages might not get installed, and that can happen, that can happen anytime. Okay, and I work I think more than 1 decade now with all this Linux system, and I've seen all themes are good, everything is good, still one package some issue happen, maybe it's a yum or maybe with apt, and all this I forgot to one add some certificate or say that fingerprint key and all these things. Okay, very minor things, but those affect very badly because of this one software installation not done properly, entire pipeline failed or entire instance creation is failed. That also happened based on some condition, of course, but these things can be managed, can be overcome, can be fixed if you know how to debug it first. So to debug it first, you should know, of course first know that these are the package manager yum, or say apt and all that, how to install, how to debug, how to fix some missing packages issues, all these things you should be learning, and you should be experimenting well. Okay. And oh no, what happens, sometimes we get, like, as a beginning when I was a DevOps engineer, I got fear if someone package not getting installed, how to do it and all. But now I don't fear at all, because of course the machines are disposable. We can just always create a new instance and add to the pool of the using or utilizing resources. But majorly which helped me was this configuration management tools, which we'll be discussing after a few slides. But there, you know what, in those instances, we don't have to do anything manually. We'll just use say package manager for particular configuration management tool. For example, Ansible. In Ansible, there is a package manager for yum, the package manager module for say apd, and using that itself we can do all this dynamically and more efficiently. So all these things will be you have to use anyway. Okay, so we talked enough about the basic Linux command and basic things that you should be understanding and knowing. What next? Let's talk about the advanced concept and tools that you should be utilizing as a DevOps engineer. And let's get started. Let's talk about them. Um, those are the system. First is system monitoring. Now, why you need to monitor the system? You need to understand if any package is not working proper, like say any traffic is not coming properly, or maybe any traffic that's going on, there's some anomaly. You have to find all that thing if anything such any incident happens. So system monitor tool like vmstat, iostat, these are the option that you show that how is the IO activity going on, how is the resource utilization on there. Okay, just as a part of the system monitoring tool. Then there is disk management. So sometime, you'll be, say you have 8 GB or 10 GB you have initially defined, then you see there's a requirement increased, and then you add the additional say 100 GB, 200 GB, but it will not just accept directly like that. Okay, or maybe you need to add additional drives. For example, you have in your one Linux system or one virtual machine, you have one drive, but you see you might require 10 additional drive, maybe for 10 different users and for their home directory. But you have to, as soon as the system boot happens, you have to mount them. Okay, and to mount them you need to use the fs tab. But if you don't even know all the about this, the fs tab command is there. There is something called mounting, unmounting. There is something like say mkfs or fdisk. If you don't know about all these tools, then you cannot achieve that part. Of course you can have to, I mean, when you there is a, no, normally what happens, if there is a requirement, you search about it, you learn about it. But beforehand, if you know say disk partitioning or this commands and fstab and all that, it will help you to do things faster, right? So it's good to know this. Now, one additional part that these days all the cloud service provider now supplying or supporting the elastic storage increment and adjustment, right? So you should be adapting to that more. Then the system logs, of course, in of course you need to some, and not just some, there are a lot of issues happen. Maybe the cloud, the instances that you're running facing some problem, or maybe there is a some tools you're running, or maybe software running that having issues. So all these software issues, all the system issues, all actually stored in a particular directory called /var/log. You can just go cd into it, and you can see a lot of logs there. Now check for the binary or the programming that you want to see the log for, and check it. And you can use cat to check the logs, or you can pull the logs and download to your local system and you can check it. So it's good if you keep if you want to see the problem in the system. For example, the kernel panics happening, or maybe the system not performing that well, you need to check the logs to find out what is the root cause of that. There you need to find the log, you need to find in the var logs directory. Then there is cron job. Now there are certain tasks, for example sending the automated emails every morning 6 a.m., or maybe doing some cleanup of some temporary data at every 12 a.m., or maybe you need to clean up the system logs or auto it. All those things, there you need to do perform some task which can be performed without the manual intervention. Those things you should be managing with the help of these cron jobs. Okay, and again all these commands and everything, if you just search about it quickly, just say cron jobs command example, you'll find it, and it's very easy to do that also. Even in my tutorial also, on my videos you'll see a lot of, I think 2 or more videos I have done on the cron jobs as well. So you'll find that there. Now the next is ssh. Now you have your one machine or your local machine or maybe virtual machine, and you need to connect with other instances or other machines. So in order to connect your local, your VM machine with other instances, there is a particular protocol. Give me a moment, I need to. So that kind of connection, that to connect with other instances, you can achieve with the help of this SSH. Okay. Now I think if you're working with as a DevOps engineer, started working with DevOps, you must be already working with say EC2 instances, and you might be already connecting with the EC2 instances from the SSH. So not nothing new, but it's good to know if you are very new to it. Okay. And then the security part. Now, basic security in Linux system are the firewalls, mainly to protect the ports, and sometimes if you want additional protection, then the user permission level things you have to fix using the last slide. If you see, there's a command like this one, right? Chmod ch1. Using that, you can choose the permission level, and you can restrict the users, like say admins, the owner administrator, or say admins should have the high level access, but the normal other users you should assign to the groups where they have limited access, maybe creating the file but not changing the system settings. All these things you can achieve with the help of um, this user permission level management and this firewalls things, if you are if you want to do it in the networking level to restrict the connections. Okay, so those are the things I will say basic Linux and advanced Linux you should cover. Now I will say this is, you might say, Sandip, is this it? I will say no, never. Because so many projects I've worked on in my the decade of experience in Linux systems, there are weird issues. Something suddenly pop up, and you have to fix it, and you may not know why this is happening, how they're happening. Then maybe it happened on the 2 a.m. or maybe it happened on the middle of the lunch. You suddenly see issues, you finish up everything and then start debugging. And sometimes if the debugging takes only 1 hour to 2 hour, sometimes some issues can take for 2 days, 3 days, and 1 week. So issues will happen, problem will be there will be things that you don't know, but you have to cope up with that. You have to start debugging, you have to start researching articles, Stack Overflow, doesn't matter, whatever it is, you have to fix it. Okay, so what I've discussed, it's needed. It's not limited to that. There will be other things as well. As you work on different projects, as you go through all these things, you will know, you will experience, you will learn more. But these things are good, are very good things to start with. Okay, and it will give you edge for other people, so which you might want that, right? Okay, so I talked enough about the Linux system. It's time to talk about shell scripting. Again, in my channel, I've already covered shell scripting, basic, advanced, even 4 times, 2 or 3 years back, and now recently, I think 2 months back. So let's talk about what are the skills that you should have as a DevOps engineer in the shell scripting. Okay, let me check any particular command comment came so that I have to answer. Looks like no, not much comment. Any questions? Of course, you can keep putting. I'm checking over in my phone, so that I don't have to show in the screen. I can just quickly answer. Okay. So any questions that you want to ask, you can go ahead and ask it. Okay, no problem. Now, what are the things that you should be learning as a DevOps engineer in shell scripting? First, the basic scripting. Of course, what is the basic scripting? Now, in Linux, you know that I talked about some commands. This is what I'm talking about. Know about the basic commands. Know about CCA, the ls. Know about this, PS. Know about all this cd, mv. All this command basic stuff you have to experience. Then those commands that you just experiment, just written in the CLI, tried, you can write as a form of the shell scripting. Okay. Now, of course, shell scripting give you some advanced functionalities. Now there is bash shell, there is corn shell, b shell. I will not go to all that because that's a very huge discussion, and that may itself take 2-3 hours, which I have covered, by the way, in my past videos. So I will say basic scripting, which involves the basic commands only. Then there is additional things such as variable. Now variable can be environment variable, variable can be local variable. Both are possible, but you should be learning about the how to use the variables, specifically the environment variable, because that will be using the most. Of course, normal variables use as it required. Then the control structure in shell scripting, just like any other programming language, by the way, in shell scripting also you have the if statement. Don't forget to close it. I have seen so many junior engineers forget to, like, starting the if and forget the fi to close the conditions or the for loop. So look at, focus more on that. If you're opening statement any condition, make sure you close that. And of course, if statement, loops, for, while, all these are there, you should be learning that. Functions, very important if you are going to write the modular code in shell scripting, which is very common. Okay, I've seen uh, many people write very good modular code using function. You should be also do the same. Then input output, like how to get input as a from a particular user using read or maybe other functionality that you want. And sometimes accept the file path, process the file, and all those things you should be learning. Then the command line argument, let's like the read one, this command line using the read method you can do, mainly reading the input from user as form of a text or number or file path. All these things you should be supporting. Okay. Then the string manipulation, because sometime you may need to do some on a backup job, or maybe some tasks where you need the string manipulation. Now bash scripting or shell scripting support the string manipulation, and there are many methods. You should search about it, you will find a lot of function like that. Okay. Now all this we're discussing about the main focus to achieve the automation. So write script to automate repeated tasks. So what we are trying to achieve here is using the shell scripting, that in shell scripting you will be converting your boring day-to-day repetitive job into automated tasks, so that you don't have to touch it, you don't have to see that anymore. So write once and forget. That is your entire motto of writing shell scripting altogether. Okay. Now um, main use cases that I have seen, um, that was a, like, in the shell scripting specifically, doing backups, sending automated emails, like compressing file using gzip or say other things. Suppose you are uploading one file, then the file actually getting compressed maybe 10 minutes, 20 minutes to smaller file, and then automatically that file getting pushed to the s3. Those things we usually do with the help of shell scripting. Automate stuff mainly, whatever the automation that's come to mind, you can do with the shell scripting. Some task or job can be easy, some task or job can be complicated, but everything is doable. Okay. Okay, so we covered the shell scripting part. Let me see messages, how it's come. Give some troubleshooting example you faced. So troubleshooting example, for example, that I have one system, not like multiple use cases, but one case what happened, a system was rebooting continuously, and I was not sure why. Company asking like, see, Sandeep, why this instance getting rebooted every time? Something's happening. So I go and checked. It was the system init script. Okay, there is one reboot command is there, which is a conditional, but the conditional is wrong itself. How did I find out? I found out from that cloud init log. So in the cloud init, you have the logs, the execution happening and all, everything is getting recorded. There I see before that line is getting stopped. Okay, so I fix that in his script, then redeploy the changes or re-get the instances, then start the fix, and no reboot happening automatically. Then other case was when kernel panic was happening. So mainly that was a memory leak in the application. Okay, so that's why memory getting utilized a lot. Normally that application should not be using more than 100 MB, 200 MB, but since there's a undefined loop going on, that's creating huge memory getting spiked up, right? So I checked this, and for that actually I use two things. First, I utilize the CloudWatch advanced memory monitoring, which I always configure if the client has the budget, by the way. And then when I saw that can be the issue, then I go and start the system in safe mode sometime, and then I go and check what is the problem from the various log, maybe using the file system commands. I check what is the memory usage, what is the CPU, what is the thing, RAM. If anywhere I see problem, I you have to first understand what is could be the problem, and then you slowly look out of that particular path. You may find the issue, not find the issue, but you're just trying to fix the issue, right? It can be anything. So you have to use your judgment, your common sense, and your skills that you have like, gather through working in different projects to fix that things. Okay, so that was about that fixing. Now a lot of such use cases, if I talked about, I will just not keep talking and this video will never end. So I don't want that. Let's complete all the important points that you need to learn as a DevOps engineer, as I've shown in this DevOps roadmap. And I'll be, as I say, I'll be discussing to the point, nothing unnecessary. I will not talk about anything unnecessary. Okay. Okay. So third one is about the programming. Wow. So we are talking about programming. Good enough. But in programming, like, many people actually ask me, Sandeep, do I need to be expert in programming? And my answer is usually no, you don't have to be expert in programming, but you need to understand the programming. You need to understand the SDLC, that software development lifecycle flow. You have to understand how from the requirement a software getting made, how people getting involved, how developers getting involved, how their thought process. Because you are a DevOps engineer, I think you are also a developer. Okay, so to become DevOps engineer, of course, having programming knowledge is, of course, beneficial. That can help automation. So we have a requirement to automate stuff. For that specific need, we need to learn the programming. But it's not limited to that, because we have to work very closely with the development teams. Now, these development teams are developing application, and their sole focus is to quickly deploy that solution to staging, testing, or production based on the requirement that we receive. If in order to do that you have to do anything and everything, you have to do it. Okay, so for example, one developer developed a Ruby on Rails application, and you're a DevOps engineer, you know Python, you know JavaScript, but you don't know the Ruby on Rails. So what will do you just hand like that, I'm not a Ruby on Rails engineer, I cannot perform that? Then they will fire you next second. So you cannot do that, man. You, doesn't matter what is the programming language the developer doing or developer working on. As a DevOps engineer, you have a responsibility to maybe containerize it, or but containerize it or not is optional, but to deploy it, and deploy it in a sustainable way. So that code that getting going to get deployed, that need to be tested well, that need to be artifacted well, that need to be first like deployed to test or maybe staging, then it need to be quality verified, and then it will be production. So there are a lot of stage you need to implement. So if you say I don't know, that's not an answer. If you don't know, learn about it, practice it, achieve it, implement it. You cannot say a no to a client, right? If they already hired you. Right? So yeah, that's one thing that you need to do. Now, let's quickly talk about what are the things that you should be learning, and I will keep it as concise as possible. So, um, having understanding of programming languages, one or multiple, I'll say, not I will limit it to one, because in my career I have learned, started from JavaScript, not JavaScript actually, it's Python, not Python, it's PHP, then I think then JavaScript, then Python, then Go. By the way, I am writing one course on Go. I will create a poll also where to release, maybe Udemy, LinkedIn, LinkedIn plus YouTube, or maybe some other platform. I will give you that choice to you. And I was actually reading book. Maybe I will share tomorrow. But yeah, main point is that I have learned so many programs. Even recently, I worked, I think last year, Ruby on Rails and Rust as well. So I have a understanding. I have a live production experience of all this programming language, which make me a perfect candidate for any DevOps position, right? So any person comes and says, Sandeep, do you know Python? I say yes. Do you know Go? I know, of course, yes. Do you know Rust, JavaScript? I say, yes, yes, yes. So I have the ready to I have a list of things that is I'm saying yes, I'm ready, right? So the more option that you have, the more leverage and the more opportunities you also have. Okay, so make sure that at least one, definitely Python, but not just limited to one. Have, like, you should have a knack to explore Node.js, JavaScript. Just not to write the programming for that. Think about the DevOps approach. You have a problem, you have to deploy one, maybe React application, maybe Python application, maybe Go application. You just get the sample code from any GitHub repo, then try to do a CI/CD out of that. That will make so much sense, and so much experience you gather from that. You may not even get that knowledge from developing the application. So because see your role, your as per your role, you have to experiment things, you have to learn things, you have to show off something, because the things that you learn, that you write code, that you implement, that you can store in the GitHub, and then you can utilize to show off as your skill to the recruiters, to the companies that you want to get hired, right? That's why it's very important. Now, any programming language, be it Python, Go, JavaScript, doesn't matter. I will say preferably Python. And assuming that as a DevOps engineer, you're going to choose your primary programming language is Python, what are the things that you must learn and you should not cheat? First, the data types. There are, of course, string, means the names and all that kind of stuff, string lines, integers, numbers, list, which is the arrays, dictionaries, which are the objects. If you are from JavaScript or Java background, it's objects, and sets is to make sure that you have unique values, and tuples, unmutable list. Okay, so all these data types is very important to learn, and you need them. Do it automation or maybe deploy application to the cloud, you need to learn them, the basic data types. Then the control structure. Now it's not a programming if there is no conditions. So of course, uh, like, just it's a factual I'm saying. In programming you will be making logical decision. That logical decision you will be doing based on different conditions. So if, else if, loop, while, comparison, all these things you have to learn to implement the problem or the challenges that you face. You have to solve them, right? You need to learn all these things. Now again, I have covered Python 2 year back, and now just 2 months back, or maybe 3 months back. So you can just go to my channel. That's enough to get started. Then module and packages. Okay, so what are this module and let me just quickly adjust it. Now it's visible. Okay, so modules and packages. So what I'm talking about. So in Python, you have access to community-wise modules, and of course, some modules come inbuilt. So if you go to Python official site, like, or just Google about Python modules, you will see lot of system modules. There are many situations I was foolish enough in my initial time. I started writing definition function, all that, but I didn't knew this already in the system library available. I can utilize that. I was so foolish that time, so silly. But it's a thing that every fresher gets started. They don't know everything, right? They start it, they experiment it, they search about it, then slowly try to learn and master it over the time, right? So that's what happened with me as well. So but I'm saying that you have the leverage, you are learning from me, so you know there are system libraries available, lot of system libraries available for encryption, for date time, for string manipulation, for integer data type conversion. Lot of libraries available, or some modules available. You should learn about them, you should implement them. Okay, so then, and there are, like, of course in system models are there, but there are custom use cases. Maybe you have to read the CSP data, maybe you have to read the JSON data. I think JSON data comes with the JSON inbuilt system module. But for example, YML, okay, or for example, you have to write a custom CSV, or say XLS file, or maybe XML file. So for every use case that you can think of, 99% chance there is already a module lying there. Some engineer was so good hearted that they have created the library for you. So you should first search for them and see that if the thing is already available in the market, openly available, you utilize them. If and only if the library not available, then you can create your own module. And now module creation is as easy as like a pie, very basic. If you don't know, go to my videos, you'll find it how easy it is. And from there you can start writing modules, start writing packages, and you can then, if you're a good hearted engineer, you can share that modular package with other people, or maybe with your juniors and team, right? So that's why module and package is very important. That's improve the code reuse. Okay, now the virtual environment. Now one thing I have seen, while I was working with one particular client, that client have around 8 different Python version, different projects. That was a nightmare, I will not disagree. I have used the Python version management to just switch between different Python version, but my life was easier because those developers was managing this VNV very actively. So which for me it became easy. I just created the VNV folder and quickly I was managing all that, because the management was very good one there. Okay, but think about the nightmare. One version you are working maybe 2.7 or maybe 3.1, and maybe that code doesn't support in for other project. It will become a big issue. So knowing how the VNV virtual environment works is very important. Okay, as even for DevOps, because you're DevOps, you have to run the application, you have to see how you can optimize the performance, you have to see how can you containerize it, you have to see how can you deploy properly in the cloud system, and then route the traffic, do the traffic routing, and do a lot of other stuff, performance metrics. You have to do a lot of things, man. So it will be better if you're working with Python projects. um, it's best practice to have the virtual environment setup is there. Okay, then the file operation. Of course, you can do file operation with the Linux system, but as I say, in the basics to medium level challenges with Linux shell scripting is easy to solve. But when the things started getting complicated, maybe the databases. So every value that the folder you're supposed to create or delete, everything may be stored in database, and based on the database instructions or say cron job, you have to do all this, like first fetch the data from the database and then perform file operation. What you will do in shell scripting? Are you planning to do that? That's a nightmare, and you will just pulling your head because so many complicated things. Like using database driver with this shell scripting is a nightmare. If you never tried, then you will understand what I'm saying. So, but with the programming languages built to work with all these libraries, all these databases, it's so easy. Just one library which is already maybe available, use, pull it, install it, like pip install, and then start using it. So easy. But that's not the case for this shell scripting. That's why file operation are very easy with the help of this um, say high level programming, for example Python. Okay, then there is networking and API introductions. Of course, like any programming language, I'm telling you, they have the request, like similar request model. I'm not saying exact same code, but they have their own version of request module, using which you can make put, post, get, head, whatever the HTTP method call you want to make, that you can make easily with a help of this request module. Okay, now there are some low level system level or maybe real life interaction or communication that you want, that you can achieve with the help of like duplex communication in simple word, that you can achieve with the socket. Now many guys don't know, but in particular this socket technology I was working for more than 8 years, and I'm telling you there is problem, one particular error code 1006. Okay, and what is the magic of this 1006? It's abnormal disconnect, and to find the reason of this abnormal disconnect is so horrible experience. But you have to find it, we have to see the possible reason. As I said, I'm talking about this because as a debugging or say as a troubleshooting that you might be facing. Of course, in HTTP request module, you can get error like 500, 502, 503. You have to keep like have the log ready. So check the logs and find out both the socket or maybe this HTTP. There will be logs available for the systems. Just look at the logs and find out what is the issue. You will find that if you check the log very carefully. I'm giving you a hint. Anytime you face the issue, check the log. You might 99% time you will find the issue there from the log itself if you find it very carefully. Okay, now the one point, automation scripting. Of course, the entire talk we just talked about is programming, is to minimize the effort that otherwise you'd have put very complicated hair pulling experience with the shell scripting, that you can do very easily. Maybe 10 API calling, maybe having so many complicated scenarios, database interaction, third party API interaction, everything you can do easily with high level programming such as Python. Okay, and of course, I know that in this request module, which you can help used for API interaction, socket for socket communication. Of course, there are OS and system module that help you to interact with the maybe file creation, maybe process interacting with the different processes. All these things you can manage with the help of this different modules in programming. So as a DevOps engineer, I'm not giving you so many things to cover. I'm giving you limited things to cover: data types, control structure like conditionals, function, how to create different function, because you'll be using the code a lot. Module and packages, because you should be using more things. um, Create a package and share with the team or maybe other people as a community. Virtual environment to reduce the conflict between different project. File operation to directly interact with the file system, create files, delete files, update files. Do it for say entire folder or maybe tens hundred of folders, because it's programming, you can run a loop and quickly interact with all the things. Of course you can do it with scripting. That's what I'm saying. In programming it's also very easy to achieve that. Then networking API call, for example, you want to make API call with different third-party API services, you can do easily with the request module, or maybe other modules are there also for that. And then OS and system modules to interact with the file system and processes. Oh, and of course there is sub process, by the way. So run the shell scripting, and if you want to run shell scripting using Python, there is sub process using which you can execute the different shell script. And of course there are other modules available which is similarly useful. Okay, so we covered a lot for programming. Now this is programming, but it is not ended, by the way. In programming, few other things. I talked about databases, right? So now let's talk about the database for programming. So for Python specifically, there is SQLite 3. If you want to do a in like in memory database, suppose you don't want to create a database, I mean you want to host a database other places, which is rare. You of course you want a database, but in case maybe it's a rapid application development, or maybe you're creating MVP, minimal viable product, or maybe just for experiment proof of concept, you just need one small quick database, and that you can achieve with the help of the SQLite. Of course it's the SQL relational data. With that you can create the SQLite DB automatically. Even if the file doesn't exist, DB doesn't exist, it will create it automatically, and then you can do the operation. If you don't want, you can delete it anytime, nobody is forcing you to keep it. But if you are going to work with different MySQL, for example RDS DBs or maybe other external MySQL instance or PostgreSQL, for that Python have different packages. Specifically, here you have SQL Alchemy if you are planning to interact with MariaDB, MySQL, all these relational MySQL DBs, or maybe MySQL. That are the same thing for mainly working with the MySQL and PostgreSQL DBs. Both are capable of handling this MySQL, and this is there is a object relational mapper ORM also there. Uh, those for the I think that's one for the MongoDB. That is object relational mapper ORM. That is for the MySQL and PostgreSQL. So you can utilize that. Okay, so we talk about the databases. By the way, database is very important. You should be focusing on that as well, even though you are targeting for a DevOps engineer position. Okay, or maybe as a day-to-day job for DevOps engineer. Now, the next thing is absolutely necessary, because as a DevOps engineer, you have to interact with the cloud system. Of course, if you are working with AWS, then there is Boto 3, which is the AWS SDK for Python, and it's very extremely useful if you are say creating an instance. Of course you can create the instance with the Boto 3. You are deleting instance, of course you can delete an instance with the Boto 3. Suppose you have to stop instance maybe at the 12 a.m, you can quickly easily do that using the Boto 3. So I'm just giving you one or three example, but whatever you can think of doing manually in the AWS, exact that same step you can achieve with the help of Boto 3 automation. Whatever you do manually, stop doing manually and start using more as an automation using Boto 3. Now, whatever you do with the Boto 3, just for the AWS, similarly for Google, you have Google Cloud Python for that, if you're using Python at all. And or if you want to do the similar stuff for the Azure, you have the Azure SDK for Python. Go and use it. Okay. Then web frameworks. Now, if you want to become a not cloud, say, and you become a web developer, these two of course is a necessary, but do we need it as a DevOps engineer? I will say yes, sometimes. You don't have to focus very wholeheartedly. That if the client asking you to maybe develop some internal application, sometimes client asks this, to be honest, okay, and we cannot say no because they're paying you us a lot, right? So sometimes they ask us to create some APIs, internal APIs, or maybe internal applications, because big application or main application, there are developers to develop that. We are the resources mainly, look over the CI/CD, look over the cloud infra, look over their maintaining of the system and all this, patching the system automatically, automation part, right? But sometimes they ask us to create internal application. We can achieve that with the help of this Flask or Django for create the web application. Okay. Okay, so we talked about application, databases, cloud SDK, and whatnot. But what about the testing? Because testing is absolutely necessary. So for testing with the Python, we have the unit test and PyTest. And by the way, using unit test and PyTest, you can generate the XML files which you can feed on the JMeter or other test feeders. So they can feed the test result, and they have a very beautiful UIs where they can highlight the test results. So you can do easily with the help of unit test and PyTest. Even there is a Google test result also that's available. With the Python you can generate the final XML. Okay, then the logging. So there is logging, of course, one package available, or module available, but there is many other um, packages available for logging, more advanced logging. You can utilize that. There are many ways. Then performance monitoring, or say profiling. Okay, so using time and profile libraries, you can measure and optimize the performance of a script. Suppose you are going to create the infra or some resources, and the CTO or maybe your team lead asking, "Arey, how much time it took to create the resource, how much time it might take to create maybe 100 resources, 200 or 300 resources." Now they're asking for a metric, and if you are not prepared, you might not have that. But of course you can quickly get that done with the help of this module, where we will say, okay, 5 minute, 2 minute, 3 minute for this one resource, for 20 resources, this is the, or this or that we have already verified using this time and profile module. So you can utilize that. Okay, so last point of this programming is about error handling, because error you are bound to do. Even I become, say, 10 to 20-year experience after 10 years, I will still make mistake, because nobody in the world is so perfect that they don't make mistake. They are bound to do mistakes, small or big, that's a different stuff, but they will make mistake. But we should be focusing how can we catch the mistake, so that we can maybe log that error, or maybe we notify the engineers, or say the DevOps engineer, release manager, or the ops team, that there is error happening, please look at that. That we can do with the help of try, catch, and accept finally. Okay, these are the some keyword I talked about, which work with harmony all together. Already have the example in my last videos. I'm not going to show you now, because then it will divert from the DevOps discussion to programming discussion, pure programming. But just know there is error handling, even libraries available, try catch code available using error catching module, which you should be focusing. Okay, whenever suppose the DevOps you write the Python script automation, you should make sure that you are doing the error handling properly. That's your responsibility. Okay, so we cover the programming whatever you want. Okay, so we started from data types, control structure, functions, module, packages, virtual environment, file operation, network API, and we end with the database requirement, cloud provider, SDKs, web framework, testing, logging, and whatnot. So many things, right? Now I have, like, there are many much more thing. I have not put all those things, because this I feel are the most important. Of course there are a number of things, but maybe when you face a project that have the requirement, you can focus that. But till then, think about this at the very basic requirement they should learn. Okay, okay, so we talked enough about the programming. Let's see if any question is there. Will there be a record of the session? Yes, because it's happening live on the LinkedIn and on the YouTube. So later on we'll have the recording available, so don't worry, just keep listening, and of course keep asking the questions. I will definitely answer them, so don't worry. Okay, let's come to the my favorite topic. By the way, I'm AWS container hero, so expect me to talk a lot about the virtualization and containerization. Okay, because that is kind of my specialty. Okay, so by the way, I did one animation. See, I don't know why this is not working. That's that container was going up and down, but anyway. Now, this virtualization. Okay, um, what is virtualization? So virtualization, and of course, let's talk about a very small line in this one. Okay, and then we'll come to the virtualization in depth. Okay, so virtualization and containerization are foundational technologies in the DevOps practice. They enable consistent environment, stability, scalability, and efficient resource utilization. And here's the breakdown. Like I'm breaking down all those things that you should be learning. Okay, first, let's understand the conceptually what is virtualization. Now, in hardware, you have your resource. For example, RAM. For example, your CPUs. for example your storage, for example networking, right? You have the physical resources that your machine use. What is the idea here? That there is a lot of resources which are not getting fully utilized. Why not create virtual machines on top of the physical hardware, or maybe on top, maybe in the physical hardware there's a software level, on top that software level we create a virtualization, so that those virtualization will separate or say divide the resources and will use the part of the resource. Maybe you have 8 GB RAM. Out of that, 1 GB RAM will be assigned to this virtual machine. There are 4 or 8 CPUs. Out of that, one CPU will be dedicated for one particular virtual machine, so that you create a virtualization layer of this machine, and you can run any application or anything uh, on that particular on that particular just yeah on that particular virtual machine. And if you need a copy of the particular application, since it's a virtual machine, virtual thing, you can easily create an image out of that or something, a copy out of that, and you can run similar copies. This time you don't need physical copies. You already have one application running one virtual machine. In that same machine itself, of course, you can run it, or maybe it's a virtual machine that you're not managing, you're not caring. It's the virtual machine, and there may be n number of physical resource. That's a separate step. But since virtual, we can create multiple copies easily, and we can run our solution or application there. That's a lot easier, right? Okay, we talked about that. Let me just okay. Let me know if you guys can hear me properly. Okay, I think okay, now it's fine. Okay, so we understand there is virtualization, why we're using the virtualization, right? Now let's talk about um, how this virtualization works. Now, if you already working with cloud system and all this DevOps, you're a senior engineer, you might know there is hypervisor is there. The hypervisor software which manage this virtualization, and there is two type of the virtualization: bare metal, which is only one software is there out of your physical machine, and using again, you're managing particularly everything just using the software. Or type 2, which is a hosted, maybe one such software is there on top of the hypervisor one, or on top of the bare metal hypervisor, which is giving you instruction how many resources you can create, like limiting you. Okay, with hypervisor 2 you have uh, limited responsibility and limited resources based on whatever the provider, the hosted provider giving you. Or bare metal, where you have full control to do everything. Okay, it's that's why type 1, which is bare metal, you have the full control. Hosted, whatever the things allowed by the hosted hypervisor software, you are allowed to do only that thing. Okay. Okay. Now, what are the tools and platforms? Now I'm going to say some word on this VMware Xware, Microsoft Hyper-V, Oracle VirtualBox, and I might sound alien to you guys, so I will not say to remember all these things in your mind indefinitely. But just know that there are hypervisor, because the virtual machine, or virtual instances that's running on top of the hypervisor. That's a very common knowledge. If you want to become a DevOps engineer or a cloud engineer, for example, and in an interview they ask how this in the cloud, how it's getting run, you have to mention that there is a hypervisor running on top of the hardware physical resources, which is basically managing this virtual, or creating, helping to achieve this virtualization. That point you should tell to pass the interview at least, right? Just not till that. Of course there is with Microsoft Hyper-V, Oracle VirtualBox, VMware. You may not need to remember all the things. Just know things are there, you can utilize them, but this is not absolutely required for you to become a DevOps engineer. Just know it. Okay, but the fourth point, this one, okay, the KVM, or kernel based virtual machine, that is something that you may need to know, because while working with the, because we'll be working with the Linux system, right, as a DevOps engineer, cloud engineer, whatever it is, mainly a DevOps engineer, and you will be working with the containerization as a part of your main responsibility. You need to know that the Docker, be it container D, be it the whatever the tool is there for using containerization, they're actively utilizing this the KVM, or kernel virtualization management, to achieve this virtualization. That is one important thing to learn. Okay, I'm not going too deep. Just learn it. Maybe if you need to go further, you can always go further. Then networking and storage. So understand, like, in of course in these virtual machines you have is using the underlying physical resources behind the scene, but you may not see or you may not access the physical directory. Using this hypervisor, this virtual machine only can assign. So you have to pay for it. For example, cloud instances, cloud resources. You actually have to pay for the resources. Say 20 GB, you have to create. You have to request that particular resource. If it's approved, then only you get it. It's not like you can just go and grab some 100 GB of from physical. You cannot do that. There is virtualization is already in place, and using virtualization you are getting the virtual storage, virtual memory, virtual CPUs, not the physical ones. Remember that part. Okay. Now there is of course NAS, SAN, all this technology available. I will not again not overload you guys. It's some technology to achieve this virtualization on the physical resources. If you're interested further, you should be learning more further. Okay, just search about it and you'll learn it. Okay. Okay. Now let's talk about the containerization. That's more important, I guess, because as a DevOps engineer, you need to learn all this containerization part. Now, core concept, because just understand that virtual machines are the direct directly you're creating on top of the main physical resources, okay, or maybe a hypervisor. But containers specifically, inside virtual machines you can create, you see, inside physical machines you can create, inside anything you can create, if it's allowed, is if the host software or the software that managing the containerization project or virtual machine allowing you to create the or have the resources to create the containers. Now you can compare the containers just like any other virtual machine, like a small, like say, how I can give the example. For example, this phone, okay, this phone is a computer. Okay, in this computer, we have different application, and say their application are small containers, small computer itself, for example. Or maybe we can create different small Linux instances, machines on this particular phone if you have the resources. Or similarly, if you have a computer, in the computer you are creating a virtual machine. In the virtual machine you can create additionally all these containers. So what I'm talking about is that these containers are just like any other virtual machine, just the minified only things, like to run one simple system, the basic thing you need is inside the container. So it's like a package which already have the OS, which have the minimum thing required to run the OS. Not every single thing that a OS offer, not that, just the thing enough to run the application or run the things that you want to run. So you can of course create this kind of containers using containers. Say first creating container images which will have the basic OS files, basic editor, basic some basic thing that you want it to have to run the OS, and then on on top of this particular image you can add the application that you want to run, and to run the application whatever you need, you are putting also those things inside the container. So it's a package that are everything. It's a wrap up to run the application, not a full OS, but a part of basic kernel that you need to run your application. That kind of way you should be thinking. Oh, main benefit: lightweight, fast, consistent, and scalable. Because it's a copy you're creating, it's a one single thing, small thing you're creating. You can replicate it if you need more. You can delete it if you are scaling or if you don't need any more. Easy, right? Now, what are the important tools or core tools available to achieve this containerization part? There is Docker. So using Docker, you can create Docker images, containers. Using Docker file, you can create the Docker images. Then build. You can build, run, and manage the containers using Docker. You can use Docker Hub, and you can in Docker Hub you can just pull the images, or you can create the custom image and push this image to the Docker Hub registry. Okay. Then container D and run C. It's also there. It's a low level CLI based like say image creation. You can create the image. You can run the image that you created inside from the Docker. You can run all those things in the container D. And by the way, Docker is built upon container D and run C. You can use the Docker, okay, but if you don't want the complexity of Docker or all those things, you just need the basic functionality. You can use the container D and run C to achieve this. You can do that. You have the flexibility. Okay. Now let's come to the container orchestration. Now, one thing is that I didn't created a separate slide to discuss what the Kubernetes thing you want to learn, because I have a Kubernetes course coming, okay, zero to hero kind of stuff. There I'm going to talk about very depth, okay, soon, maybe December I'm going to release that one. um, so that one you will have it there. I'm not going to too deep. Just know what are the concepts that you need to learn in Kubernetes. You need to learn the pods, services, deployment, replication, configuration management, configuration map, very important. Configuration map part, people get very confused there. Then Kubernetes architecture, like where is the master node, worker node, all others components like EDC to store the key value, kubelet, then all this thing, and there is kubectl to manage the Kubernetes cluster and the components. So all these things you should be learned as a part of the Kubernetes. Then Docker Swarm, it's a kind of similar kind of functionality concentration, but more Docker focused. Okay. Then OpenShift, which is Red Hat's enterprise Kubernetes platform. You can also try that one. Okay, I'm not going too deep, just going through what are the things that you need to learn to become a very good DevOps engineer, and you should be doing all the experimentation. And there's, of course, a lot more that I'll be discussing maybe at the end of this video. I want to complete within 2 hours. That's what I'm trying. Let's see. Then the networking and storage. So what about this? So networking and storage in see, you in your machine you have storage hard disks, right? But in container it's actually a bit special, because if you don't specifically mention that the data getting created, that should be stored in the physical place or somewhere more persistent, by default your data get destroyed the moment your container die. So you may need to provision the storage such a way, if it's very crucial, for example, databases, you need to create or and store the databases in a persistent storage, and the things that you don't need, maybe temporary containers, you don't need to store the the storage and all that, that you can just do FML, which is okay to get destroyed and not storing it. Okay, so in the network and storage part of the containers, understand the container networking solution like Calico, Funnel, Web, which is to connect different container, create a virtual network level paths between different containers, and then you can share the data between all these other containers if you need, and create a microservices architecture if you have the requirement for that. And of course you need to also understand the persistent storage solution for container, like persistent volumes and persistent volume claim in the Kubernetes. Now in Docker also you have different drivers that you can utilize to store the data permanently or ephemerally. Similarly in Kubernetes, if you're handling things in Kubernetes, then in Kubernetes you have to learn how to use persistent volumes and persistent volume claims to store the data permanently. Okay, should be understanding all that. Now I have just covered the basic requirement of the containerization. One few more points for this containerization part is the security, because there are certain things you need to be to keep in mind while you are running your application in the container. Specifically, I will say scan the container. There must be or might be some vulnerabilities that can be fixed or can be rectified or can be improved, or you can improve that one if you find out what is the issue there. Like maybe one DDoS attack is hidden behind your image, maybe some library is stealing your information. That can happen, right? So that you can quickly find out, and most cases, many open source libraries are there which help you to scan your container. And of course, for example, Aqua have the tools, like Twistlog is there. Even in AWS, say for example ECR, if you store, there is a functionality you can scan your image and they'll give you all the issues that it's fine. So there are many solutions available, you should be utilizing that. Now since we talked about the registry, understand how Docker Hub, Koyo, or maybe ECR, or maybe Google Container Registry or Azure Container Registry, how this container registry works, how you can upload your container image there, which is more cheaper, store there, right? Then logging. So like any other, maybe for instances virtual machine or maybe your instance, you keep tracking of the usage data, right? Similarly, for container also you should be tracking the utilization of the resources, CPU, RAM, if for example one pod or maybe one container spiking very high, you need to know, you need to get notified, you need to fix this so that not every container or every pod started reacting like that abnormal way, right? So you should be knowing all that part. So logging and monitoring solution, you should be focusing specifically using Prometheus for monitoring and Grafana for relation. Now it's an open source solution. There are other solution also. For example, ELK stack for logging particularly, where you have Elastic, Surge, Logstash, Kibana to store the logs and visualize it. Okay, and there is EFK stack, which with the Fluentd you can achieve that. Now Fluentd is actually a very good one. It's small binary library. It's easy to integrate and it's uses less memory, so you can give it a try as well. Okay. Oh, we talked about the containerization part. Now let's talk about the another very important. And let's take up 1 minute pause and see any message coming um, here and there. We'll just quickly check because we are learning a lot faster, right? Okay, one question came that's how to manage version in GitLab or best practice. Now for GitLab, of course, I'm doing a course, so I will cover that in very great depth there. So don't worry, we'll do that there. Okay, for the GitLab part. Hey Piyush, Gaurav, a lot of people are there. Is there any bootcamp playlist available? Yes, go to my channel, go to the my channels, that is Learn Tech with Sandip, or just search by Sandip Das. You will find it there, and go to the playlist. You will see Cloud and DevOps Bootcamp there. You can look at that one. How about the PowerShell yeah, because I mean, most of the cases the instances are actually in the uh, Linux. That's why I told Linux. But if you are going to work with Windows system, of course there is PowerShell is there. You need to understand and learn that one. Okay, any other questions? Also share DevOps, fresher opportunities. Okay. Okay, any questions? Keep it coming. We'll definitely cover all those things also. Okay. Now let's come to the CI/CD. I think you guys are more interested right, in CI/CD, right? Now this is one of the um, major skill or major responsibility that you need to do or you need to perform. Now in CI/CD, what are the things that you have to do? So what are the things? First is that like let's first understand why you even need it. So continuous integration and continuous development deployment delivery are fundamental practice in DevOps methodology, and they ensure that the code changes are automatically tested, integrated, and deployed to production, leading to faster and more reliable releases. And let us break down the code concept. First is the continuous integration. What is it? It's the practice of frequently integrating code changes into a shared repository or Git repo, and it should be automatically tested in the DevOps pipeline. Okay, and there is then continuous deployment and delivery. There is some confusion is there. Let's quickly go over that. So continuous deployment is the automated deployment of code changes to production without any manual intervention and manual checking. For the continuous deployment, for continuous delivery, there is continuously, of course, automatically build, automatically tested, but before moving to production there is a manual check required, and that's the only difference between the continuous development and continuous delivery. That's all is there too. Okay, now there is then build automation. So what is this build automation called? So while when you're pushing the code changes, when any developer pushing the code changes, that moment a pipeline or a process should trigger, which pull the code from the GitHub repo. It should maybe inside a container or maybe inside an actual physical machine. It will try to build the final runnable code and run it and test it. If you have the test cases, it should run the test cases and do make sure that the change are working fine. And that come to the next point, which is automated testing. So whatever you got the final code, runnable code, you are just testing, you're running the unit test, integration test, and the system test automatically. That's in the automated testing. Then what? Then you have deployment strategies. Because now if you are just for deployment, you can just quickly restart all the instances if you need, but it's not practical, man. If you are going to restart all the instances, it will it will create a huge spike, and your all the services will get unavailable for next maybe 1 hour, 2 hour, maybe entire day, maybe next 1 or 2 days. You cannot do that. So to achieve the sustainability of running and deploying the changes, you may suppose you are running 100 instances. Okay, what you can do, you can give me one moment. So you can of course can do rolling update like one by one by one, or you can do like say 100. That means 10 by like say let's do in 10 step. So 10 first lot 10 instances, second lot 10 instances, or maybe let's do it smaller. I know that this particular timing when the deployment happens, 30 instances are enough which can handle the workload, and then automatically scale up or automatically scale towards it, the distribute the traffic to when the all this is up. Okay, it's up to your understanding, your user base, your use cases. You have to make the final decision how the deployment should be happening, be it rolling deployment, be it blue green, be it say part by part deployment, whatever it is. That's like canary deployment, whatever it is, that you have to make the decision based on your user statistics, your workload. Okay, so it's up to you. Now, let's come to the next points, that is the continuous integration. So, understand how, sorry, container integration, because most cases, you may need to do like run the your application. You are creating a container image itself, and that container image you want to deploy to maybe Docker Swarm or maybe say Kubernetes. So, you need to understand for Kubernetes how you're going to push it and how going to restart or do this rolling update process. Then you need to learn, then the infra as a code. Now you like we'll discuss a bit after a few slides, but you can create infrastructure as a code, right? And that infrastructure code you can provision in the CI/CD pipeline. So one developer making change in the infrastructure level, and they don't have the direct access to the cloud, they have to push the code changes that has to get approved by a senior engineer. Suppose they are creating one machine learning instance, that's a huge expense to be honest for the company. So that's senior engineer should review or release manager review, and they think okay, this is required, we have the approval for that, let's approve it and create the instance that you can utilize it. That way you are doing double check to make sure that you are creating the resource that actually needed, and you are not over estimating or over creating the resources. Okay, and it's a seamless automation process and less access prone, like less issues to have open access. We have to reduce the access, right? Like whoever need access only give them, otherwise like do your code change via the code, and using GitOps kind of technology will do the deployment that way. Then artifact management. So knowledge of artifact repositories like Nexus, Artifactory, Azure Artifact Store, and manage the build artifact is very important. Of course, I forget to mention the JFrog. JFrog is also a very good service to store the and using the artifacts. Then the security. So implement the security like best practices. Of course, just can Google about it. I have shared so many articles. Maybe I will write more articles on this, the best practices. But it's mainly where you should be focusing is the secret management. So no secrets getting stored in the code or anywhere in the even in the log. You should not store or pin the secrets. Then code scanning. Of course, there should be a code scanning even before you start the building, because maybe the CI/CD code you're going to run, and you're going to execute one script that has some problem, that is some destructive. So for that case, you might want to do the code scanning before even doing the actual start the build process. So you need to make sure that you are doing all these things. Okay, then familiarity with tools like SonarQube for static code analysis and SNYK for vulnerability scanning, specifically for say, and I think it support many, but Node.js what I've seen very effective using the SNYK. You can do find a lot of issues. Okay, a lot of security issues. Then the version control integration. Now with CI/CD, deep integration with the version control system like Git, understanding hooks, trigger, pull request workflow are extremely important. Okay, not just to storing the code and blaming, it also required not and not to the limited to version management, but hooks, triggers, pull request specifically is very important, because that based on those things, those triggers, you need to deploy, you need to create separate branch, or say do perform Jenkins multi-branch pipelining based on the pull request. You can do all those stuff. Okay. And there's three or four more point are there. So parallel build. So yeah, in CI/CD, if you're if you're creating a CI/CD, you should be utilizing parallel CI/CD and caching, because if you do use caching, then it will utilize the less time to make the builds. Okay, so that it can save more time. You don't have to say the build. If you can reuse the past build as a base for the new builds, it might say reduce the timing from 1 hour to only 10 or 5 minutes. So you should be more checking towards that. Don't just, okay, it's working, it's fine, 1 hour, let's pay it 1 hour. No, that's not the right way. If you can reduce even 1 minute, do reduce that. That should be your strategy. Okay. And of course, you should be reusing previous build step to reduce the number of the step that you required for the CI/CD. Then the environment management. So what is the environment management? So if you are going to work with the production, like there are different environments: development, staging, production. You should be actively managing them. You should be using more infra as a code to create specific environments. And while even creating the CI/CD itself, you should be using infra as a code tool as a CI/CD process, so that you can make everything dynamic. Okay. Now it's something that you should be seeing or observing. Maybe I will plan for one particular, no, maybe not live but a recorded one, to how to, I mean, I create one or two videos in my past videos where I create dynamically the CI/CD pipelines. So you may check that one, or maybe I will create more videos on that. Now, monitoring and feedback. Now, for any CI/CD pipeline, one of the most important part is the monitoring and feedback, because it's not a it's an infinite process, not a one time process that, okay, it's deployed. No, it's not that. Every time you deploy, there will be problem that need to be fixed. There will be new features, new old issues, bugs that need to be fixed. You need to feedback. There's a feedback loop continuously going on. Those things you need to put, like you should be having cloud monitoring for instances. You need to have performance analytics or performance metrics. You need to have error logs, so that you can forward error logs to the engineers. You should have all those things to make sure your things work well, your CI/CD works perfectly. You need to have all these things. Okay. Lot of the things I know, but everything is required, you cannot miss it. Okay. Now, I have covered the most important part that should be learning and should be focusing as a part of the CI/CD. What else? Like, what are the um, most popular CI/CD tools? The first one I will say is the Jenkins, because it, I mean, and what are the things required for Jenkins? You should have the familiarity with the Jenkins pipeline, both declarative and the scripted. So it is the groovy scripting. I will say first, just quickly, easily get started with the declarative. Slowly, you will see you have the complexity increasing for your project. Then only you introduce the this scripting part. Okay, that groovy scripting. Now, with that, additionally, you need the Jenkins plugins, nodes, and execution. All this knowledge you need, and of course, it's like the base is the source, right? And source is the git, so git integration is also absolutely required. And while going through all this thing, for production level, okay, you need to learn and implement the multi-branch pipeline. It's actually super easy. Maybe some other session, maybe next week itself, I can show you how to work efficiently with the multi-branch pipeline. So Jenkins, you should be focusing on all this. Now, what about the GitLab series? The other, like this, first understand what are the main tools: Jenkins, GitLab, GitHub Actions, Travis CI, and Circle CI. First one we covered the Jenkins. Now, what is the GitLab CI series? For GitLab CI series, it's of course you now know it's for GitLab. There you need to understand a particular file and the file's syntaxes. That is GitLab CI YML configuration file, and get familiar with the runners, stages, and the jobs. Now, any CI/CD pipelines have their own version, own definition of the runners, own definition of the stages, and this jobs or task. But after working say 8 9 years purely on DevOps things, I understand all things are kind of same. It's just running commands and some task, nothing out of ordinary. So understand Jenkins well, it will help you understand everything very easily. Okay, so focus on the Jenkins if you're just starting fresh DevOps engineer. Then slowly you start exploring GitLab, GitHub Actions, Travis, because everything is pretty simple. Just start, like, first understand what is syntax, and ultimately in the beginning you will be running the simple Linux commands only, so nothing out of ordinary. And but there are some say platform specific features that you can later on experiment, later on try. Just understand the basic first, that's more important. Now, for the GitHub Actions, understand how to create the workflow file and YML syntax, because for that you need to know the YML. For, of course, for GitLab also you need to learn the YML anyway. But anyway, learn the YML. I have one particular. If you go to my video section or live section, I think YML crash course is there. You can follow that one. Okay, so YML, learn that. Utilize the marketplace action for creating custom action, because there are so many actions already available for Docker, for Kubernetes. You may want to reuse those. Okay, so you should be utilizing that. Then let's talk about the Travis CI. Of course, for if you configure using the Travis .yml file, understand the syntaxes and understand how you can integrate with the GitHub. Again, similar for the Circle CI, understand how the .circle CI slash config .yml file works, all this, syntax and structure and all that, and understand how to interact with this Circle CI and how to work with the workflows. So these are the things that you should be focusing. I will highly emphasize on first start with the Jenkins, then only you start explore all other tools that I talked about. Okay. I think one question for Sammy is very good one. So, which one are we going to pick and learn? Um, Now here, I mean, I have already covered Jenkins, GitLab, GitHub Actions, all in my channel. I don't want to kind of recreate things. But yeah, for example, the GitLab actually is still in progress. Maybe that one I'll be covering. But Jenkins, already 2 or 3 videos are there. You can focus on starting from that one. Okay. Okay, so we talked about a lot of things, lot of tools. Now, one of the things, without them, nothing gonna work. Like say, anything that you want, Jenkins, anything they say, even your GitHub hosted repos, everything actually running where it's in the cloud, right? So you need to learn cloud, man. There is no alternative. You cannot think of surviving in the industry now or in the future without knowing the cloud. Mark my word, without cloud your career never gonna grow. You have to learn cloud. Now, in cloud, what are the things that you should be focusing on learning? But before that, why even you should learn the cloud? That's important, right? So cloud platforms play a pivotal role in the modern DevOps landscape, because every, like, ultimately you are creating the virtual instance in the cloud. You will be dynamically creating or using infra as a code or other means like container management. Everything you are ultimately, what is the target? Handling the virtual instances in the cloud. So the cloud becomes like, without, as I say in my past video also, there is no cloud without DevOps and there is no DevOps without cloud, because so tightly integrated these days. Okay. Now this cloud provide the scalable infrastructure. You can, like, that's, you can create different infrastructure, staging, production, QA, so many resources, and you don't want anymore, quickly delete all these resources. You have that kind of luxury and flexibility with the cloud. Okay. Now, and this helps us to achieve the automation, advanced monitoring and deployment, because most cloud have their own tool. Also you can quickly configure and integrate the custom or open source tool as well, or cloud native tool we call these days. Okay. Now I have break down what are the basic thing you should be learning in the cloud to become a DevOps engineer. First, learn about the infra as a code. I will just give the technical jargon that you should be focusing on. Again, I have covered in my boot camp. You can maybe I will in the video, after video ends, in the comments or maybe in the video description, I will give it. You can also go to my playlist or my videos and you'll find it there. Okay. Now, infra as a code, platform as a service, software as a service, these terms you should be understanding. Then understand the elasticity, scalability and high availability, why these are important. Then very important is to understand the cloud pricing model. And the mistake that these days people do, they don't care about the cloud pricing model. They don't focus on the cloud cost optimization strategies, like using reserve instances, or maybe using the spot instances, or maybe reducing the instance usages, or like maybe in the night if the user in India, for example, they're sleeping after 12, right? So you don't need too much workload, you can reduce the instance numbers. Those things you can achieve if you understand the pricing well, you understand the automation and cloud well. Okay, so you have to create all the strategies. Now in the cloud itself there are basic pillar, which is what? Compute, instances, CPU, memory, RAM, all those things, networking and all that. Then you have the memory, is various the storage, where you're going to store for long time, a permanent time. Then the third is networking, where you are doing all this, input from the people, giving the responses, dealing with the internet traffic, giving the response to traffic, all those kind of things you're achieving with the networking. And then finally the security, because you need to make sure the communication is secure, the user directly controlling the cloud resources have the authenticity or authentic users, they have the authorization and all. So which is the basic stuff that you should be having, or you should have the understanding of. Okay, again I've covered this in my last videos so you can just go and check it out later, not now. Stay with me now to finish these things. Now there is cloud networking, as I say. It's a part of the cloud basics, but just mainly focus on the BBC and the firewall and the security, because there will be more focusing from where the resource coming, which traffic to block, which traffic to allow, which float to allow, which float to block, or maybe which IP to allow, which IP to block. All those things you can control with the help of BBC and the BBC related resources, for example firewalls. Then security basics. In security basics, there is you have to focus on the identity and access management, that is IAM, and encryption. Okay, these are the core topics should be focusing as a DevOps engineer. Now I have created a very simple not diagram, simple comparison. So because right, it's the currently three cloud leaders are there, where you are going to work as a DevOps engineer, be it AWS or Google Cloud or Azure. These three are the max to max, any of this, or maybe multiple cloud you have to work on. So I have given what is the compute, what is the compute for the AWS, what is the compute for the Google Cloud, what is the compute for the Azure. All the names are given. Again, you may not need to remember, but you should be more working, or so you'll be first learning the cloud entirely, all the core resources, core services, and then implement it. Just not see the names and remember that, not gonna help you anyway. Just as a reference I've given it. For example, AWS compute is part is that EC2, Lambda, Elastic Beanstalk, auto scaling. For storage you should focus on S3, EBS, EFS. For databases, RDS, DynamoDB. For networking you should focus on VPC, Route 23, API gateway. For management and monitoring you should focus on the CloudWatch, CloudFormation, and AWS config. Developers tools, that is CI/CD part that you are most focused on. For the cloud there is code commit, code build, code deploy, and code pipeline. You should be focusing on for AWS. As a DevOps engineer, where should you be focusing for the Google Cloud is the compute part, compute engine, app engine, cloud functions. For storage, cloud storage, persistent disk. For databases, cloud SQL, Firestore, and the big table. For networking, virtual PVC, the virtual private cloud, DNS, cloud load balancing. For management and monitoring, stack driver, cloud deployment manager. And for development tools, cloud source repositories, and cloud build. For Azure, for Azure compute should focus on virtual machines and Azure function and app services. For storage in Azure, focus on blob storage, disk storage, file storage. For databases, Azure SQL database and Cosmos DB. Cosmos DB actually very famous, by the way. Then in the networking, same virtual networks, Azure DNS, content delivery network. For management and monitoring, focus on Azure Monitor, Azure Resource Manager. For developer tools, Azure DevOps, Azure Repos, and Azure Pipeline. These all the services and tools you should specially focus as a if you want to become a very good DevOps engineer in general. Okay, that I need to cover for the cloud part. Oh, so many things I am covering, man. Now it's good that you are going through all that you have learned, right? Now. So we talked about cloud. Now two topics are remaining. First, like out of that two topics is the configuration management. Now I just created a robotic dance because we dance with this kind of machines and everything, all this configuration management with the help of automation, by the way. So Yes, so we do automate. We do automate a lot of stuff. So what there is a real life use case, we create instances or compute resources in any cloud, for example. And in those cloud, what happens, you create the resources, but using Terraform or all these IAC tools, which I'm going to talk after a few slides, you cannot manage the instance. To manage the instance, to patch it on a huge scale, say 100, 200, 300 instances on that scale, you need a configuration management tool. The end. You need to use that, man. There is no other way. You need to use a configuration management tool to control, to patch, to manage all the resources that you have created either manually or most preferably, or that I want you to create more via the IAC or infra as a code. So you should be, it's a kind of hand on hand, it's kind of sister components. Configuration management and configuration code, kind of sister tools which work together in harmony. Okay, so in configuration management, this translates to what, what in automation, what we expect or what you should learn. First, configuration management is a critical component in DevOps landscape. It ensures that the systems are consistently maintained in a desired state, allowing it to scalable automate infrastructure management. And I will break down whatever things are required now. Code component, idempotence, so the ability to run the same configuration multiple times without changing the result after the first run. Extremely important, okay, because you are going to run a replica of the resources for auto scaling. If one machine's in configuration is different from another machine, the application is going to run not going to work. So to make sure all the system running same configuration, so that it support the application that is supposed to run. Nothing, if something doesn't work, that's a problem. Okay, then coverings, okay, the process of moving the current state towards the desired state. So when you write a configuration code, as a configuration code, for example, you are writing, you are expecting that tool to create one particular state or destination state. You write, you executed that particular configuration as a code scripts, it creates the state in a particular machine. Then you make another change, and that change then you're going to deploy to other all these instances. Now there is a something that you want, and there is a state which is a bit different. So using this configuration and code tools, ultimately what you're doing, you are creating your desired states. For example, I'm giving you, in a machine you want nginx to be installed. Okay, so you run and you and this configuration is a code tool, and you install the nginx there. Now after 2 days there's a requirement come, no, 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 we don't want to run nginx, we want to run apache. So now in those 10 machines or 20 machines you have running nginx, and you plan to run change that with apache. So existing state is the nginx, desired state the apache. The moment you execute the code, then those code will uninstall, for example, the nginx systems, and install the apache server. So all these things, what is existing and what is the destinate, this final state that you want, that is the thing that you're creating. Okay, now version control for this configuration. So it's a version as code, so configuration as a code, remember the part code. Okay, so one of the very important part in this configuration management, treat your infrastructure, treat your resource as a code. So whatever script that you are writing to achieve the desired state, you should store the codes in the git for future references and for the version management, so that anything's code bad, you can always revert back to previous state using the just git reverse, or just go to the previous commit. That easy it is. Okay, now secret management, make sure, as a if you want to become a very good DevOps engineer, don't ever store secret in the code. That's it. Don't store the secret in your normal code. Instead, use tools like HashiCorp Vault, AWS Secret Manager, or Azure Key Vault to store the secret there, and then use that in your application or your infra as a code script. That's the absolute requirement. Okay. And what are the popular? Oh, I think Okay, yeah, infra as a code. I think I was talking confusion. Yeah, I thought why I skipped. So yeah, so what are the most popular uh, configuration management tools are there? Now there are actually many, but I personally believe these three are the most uh, most popular ones. Okay, first one is of course my personal favorite, Ansible, which is like in Ansible what should be focusing, understand the agentless architecture of the Ansible, become familiar with the playbook, rules and tasks written in the YML, have the knowledge of the Ansible galaxy and the community repository. That's all I'm asking in for Ansible. For Chef, if you at all want to learn Chef, grabs the domain specific language for Chef, the recipes, cookbooks and roles, then understand the difference between the Chef server, Chef solo and Chef zero, and they have the knowledge of Chef supermarket and the community repository. If you want to go for the Chef, or maybe you have to work in a project that is utilizing Chef. For example, if you're using Puppet or you are planning to use Puppet, understand the declarative language of Puppet's manifest, knowledge of Puppet's mastered agent architecture very important, and become familiar with Puppet fork where the pre-built modules are available. Okay, so these things which will be focusing. Now, if you ask me Sandeep, how to test, now understand, because in this configuration management there are many ways to test it. For example, become familiar with testing tools framework like server spec, test kitchen or molecule. You can achieve the test requirement there. Okay, like, or you can just simply first you should group the resources or the hosts, first run in the for those test instance to make sure the things are not going bad, and then only do run in the staging or production. Okay, that's you should be having your own strategy. Okay, I think the final part is now coming, and I know that you guys are interested for this final piece of the puzzle, that is infra as a code or infrastructure as a code. Now, why I keep keep this in the very end, because you should be having all the things that I've discussed to achieve or to come to this current state, because now we are talking about everything that you learned: virtual machines, virtual networking, cloud resources, Kubernetes, every single thing you can create as a code. That is infrastructure that you are creating in the cloud services, or maybe other any cloud services as a code. That's why it's understand. Like, I personally prefer to or suggest you to focus on this after you learn all these basic things that I discovered. Okay, so what you must learn: infrastructure as a code or IC is a key principle in DevOps paradigm, allowing infrastructure provisioning and management using code and automation. Here's a breakdown. I have breakdowns. What are the things you should be focusing on learning? First, the core concept, which is what is immutable infrastructure. Now, this idea is actually provisioning the new infrastructure for any change rather than alter existing. You can focus on that, but remember that will be incurring a cost. So it's your own decision. But sometimes it's okay. You don't even have to do this immutable infrastructure. You can update your existing infrastructure based on the use case. Okay, because this immutable infrastructure concept is actually kind of a red, so blue green deployment kind of concept. But anyway, then the declarative versus the imperative approaches. Understand the difference between the definition, the defining the desired end state, declarative, and specifying the step to reach the state, so imperative. This concept you should be learning. Okay, then the version control. All this ISC code that you are creating, you have to be stored in the Git and treat it just like you treat your normal code. So normal code, what happens before deployment? You have to do this pull request and code get reviewed. Same for creating, before getting this is created in the actual cloud, it has to get reviewed via PR, or the developer has to review it. Okay, so that, those kind of thing you should be expecting. Then configuration management integration. As I told you, it's sister components. So the things that you develop or so you deploy or you create using infra as a code, you should be managing with the this Ansible, Puppet and Chef. So learn how these two or multiple tools work together. And I have a very good planning coming up. I'll show you practical way in upcoming sessions. Okay, um, example I was given, like you might create Terraform to provision a virtual machine and Ansible to configure the software. Like, that's very pretty common these days. Okay, then is that state management. Now, this is probably one of the most important but neglected part while dealing with this infra as a code. So whatever, when the code you're running, Okay, whatever Terraform code or whatever in ISC code that you're utilizing, you're running, it creates a state. So it should create a state file where it should specify what are the resources a component got created, so that next time you make any changes and related to the change, the resource get altered or deleted or added based on the differences between your desired state in your script and the actual cloud state. For that reason, it's extremely important to know how the state work, how to migrate state, how to modify the state, and all those things. It's very important. Okay. Now, I talked about the state and all that, but I think important part is actually understand what are the key tools or major infrastructure the code tool available in the market, and how to test it. Let's first understand, focus on the tools available. The most popular one, of course, I will. It's anonymous. Okay, it's everyone will agree. Terraform is the most famous infrastructure as a code tool available in the current market, and in Terraform, what should be focusing? But just so you know that in my channel homepage itself, I have a Terraform full course available. At least you can say, if you want to get quickly started and learn and get certified, you can focus on that. You can prefer that one. Where in Terraform, it's expected that you should have the basic understanding of the HashiCorp configuration language or ACL, knowledge of Terraform lifecycle commands like init command, which is to initiate the project, then the plan command, which is to show you what are the resources going to get created, apply to actually create the resources, and destroy if you don't want the resource anymore. Okay, but there are some situation. Even in my today's class, also I was teaching these guys, my student today, that destroy command is dangerous. If you want to delete the resource, of course you can comment the code and the resource will get destroyed, but maybe in future you need it, or maybe based on some condition you want it. So that for that reason, in Terraform you need to learn about this count, you need to learn about the conditional, you need to learn about the dynamic block, and all those things you should be learning. So learn about all those things in the Terraform if you want to achieve the dynamicity and more production level application codes. Okay, then familiarity with the Terraform state manager. Of course, this is absolutely necessary, and how to store the states in the backend. For example, S3 backend, or maybe for example, Google backend. So all this backend, how can you store it? Okay, should be focusing. Of course, Terraform Cloud also have the support for it. If you have the money, you can do there. But I prefer the S3 with DynamoDB state locking. Absolutely fine. Then you have the modules. So for unlike Terraform, you have different modules openly available, and even providers available. You should be utilizing them actively. Now the next one is the AWS Cloud Formation. So grabs the domain specific. Okay, I think I copied the wrong stuff for Chef. But yeah, for AWS Cloud Formation, focus on the Cloud Formation templates and nested blocks. For Azure Resource Manager, skip the AWS Cloud Formation. I by mistake I I forgot to paste properly. Okay, but anyway, I told you, just focus on my words. For AWS Cloud Formation, you should be focusing on optimizing the Cloud Formation template and nested Cloud Formation templates. Okay, and of course templating to reuse the code components. For Azure Resource Manager, you should focus on grasp the structure of ARM templates and understand Azure specific resources and configuration. For Google Cloud Development Manager, focus like get familiar with the structure of configuration files and understand the GCP specific resource and configuration. For Pulumi, knowledge of defining resources using general purpose languages like Terraform, Python, Go, and C Sharp is required. So you need a programming language by that. For Pulumi, actually, I work only on two production level projects. I don't get much projects on Pulumi. I don't know why people don't hire me for Pulumi. Maybe Pulumi, not many projects in the market. That could be the reason also. But it's good. Pulumi is a very fine tool. It work. You can just use any choice of your programming language, and you can then utilize that to create resources in a particular any cloud that you want to target. Okay, now understand the Pulumi lifecycle and state management. This state management actually work not exactly but similar to like Terraform. So if you understand Terraform well, it will be very helpful to understand Pulumi as well. Now the next one is testing the ISE. So of course you can create the infrastructure and all, but it should be testable. Now for Terraform specifically, there is Terra test and there is kitchen Terraform, which you can utilize for testing purposes. Now whatever ISE tool that you use, no matter what it is, make sure it's modular. So create more modules and reusable. So you should not repeat yourself, like once basics particular resource you are creating again, like copy pasting. Don't do that. Create a module and then reuse the module. That is the best practice there. Okay. So yeah, that is all I wanted to cover as a part of today's session. That is to you know have this achieve this DevOps. I just not talk about the tool and tech. I want to cover every aspect, every thing that you need to have knowledge and experience in order to become a successful DevOps engineer. If you focus on this thing that I've shared, I think you will be in a very good shape and you will be ahead of other normal DevOps engineer, like a real overpowered DevOps engineer. Now, if you say that I am a some one people was like, "Are you an overpowered DevOps engineer?" Could be because I have most like I have skill over all these things that I talked. Even more than that, I have multi-programming, like say we call it polyglot programming. So I have this skill that is polyglot programming. What I've as since I've worked on so many programming languages, I can work with any programming, or I can even work with mix and match of programming languages. Okay, so that's why it's a kind of skill that will be very helpful if you want to become a more uh, demanded DevOps engineer. Okay. Now, let's see what are any question. Now, this is the question time for 10 minutes. I will, I think it was already 150. So, for 10 minutes, it's all question time. QA. Let's see what are the question I got. Question I got when course will launch. I know which one. Git CI that GitLab CI series soon, maybe next week. I created the course, but I didn't like the quality. Sometimes we as a creator don't feel the quality is good enough. We discard it. It's completely fine. I think many creators do that. I created it. I personally don't like it, so I didn't release it. I say, okay, let's do something better. I can do it better than what I've done. So that's why not release it. I will make it release next week. For other example that I talked about, or the other tutorial, we'll see next week or maybe the next week. We'll definitely cover those. Okay. Why TerraGrant? TerraGrant is actually good. If you want to wrap, there are additional functionalities specific to TerraGrant which you can grasp with the TerraGrant if you just wrap your or say create or say run with TerraGrant. Kind of additional functionality. You can just go to the documentation. You find a lot of new features and list that you can achieve with the Terraform, which is missing from the Terraform. Okay. Jitesh saying, I want to join the DevOps class. Please guide. Right now, one batch is going to complete. I was running as a kind of a pilot batch just to see can I do it. And now there are many people. Some people actually finish the DevOps courses within maybe 1 week, 2 week. I don't know how to do it, but they do it, which I cannot agree with them because it takes a lot of time to learn things and perform things. And it takes time to do everything, right? So um, I don't do it. I do take 5 6 months time and train people, give them time to do some projects as well. So last time I started with around 10 people, and as a said the pilot project. So see, I can do it or not. I can do it. They have the I think we are finishing line now. I mostly cover the Terraform. Now is only Kubernetes classes and some interview classes, like how to prepare the interview, resume making, all those things are remaining. Those after done, I maybe from the January, I will start the next batch. And if I'm available, I'm planning to take some additional project workload. But if I get time, I will simply do it. If I don't get time, maybe I will just do with 5 10 people. We'll see how what I can do. Okay, so one question that came from Steven: what is the cheapest way to get started learning with DevOps with AWS? So in Terraform, if you go to Terraform GitHub repo, there is 3 type application, 2 type application. I mean, in if you follow me on LinkedIn anyway, you see I always share, or in YouTube videos I've shared the code samples and all that. You can simply utilize them to quickly create it and do that. Now in if you go to my YouTube channel, by the way, there is a particular series or playlist DevOps with AWS. You can go and first create, say, code commit repo, upload the code there, then create a pipeline, say, with AWS code build to run the builds, for using code pipeline, you do the workflow creation, then add the code build, then use the code deploy to deploy solution in the EC2, in the load balancer and all. So all these things you should be experimenting. Now, as I say, in my YouTube channel, there is a particular one series called DevOps with AWS. You can follow that. Your all question related to the AWS DevOps will be answered there. Okay. So what are the agro CI/CD tool kind? Agro CI is good. Um, I have limited experience. If I be honest, I have limited experience with the agro CD, but it's good. You can start it. Since I didn't experiment it too much, I am not that certain is it perfect or not. Okay, it's good. I'll say. For large scale project, state file become too big. Any ideas, recommendation, breaking down state file into multiple files? There are ways. There are many ways to achieve. But what I will say, use the module as like module as much as possible. That will be like, it will not help you to reduce the file, but store the state file in the backend anyway, right? You don't care about that much. You are not going to edit the file manually, so it should not be. um, Monitoring and observability. Actually, yeah, when I talked about the container part, for example, then I talked about the say this monitoring with Prometheus and Grafana. When the CI/CD part, I talked about importance about. Now there are n number of tools, right, to collect the logs. Say ELK stack I talked about. So there are tools and available. I didn't create a dedicated because it's part of the DevOps process. It's part of the DevOps pipeline. So that's why I didn't create a dedicated part here. Okay, but yeah, it's equally important, not dedicated yet. Is Ashish saying that certification is important? If I give my true feeling, that might create problem. But certification are important in terms of learning. If you are, if you want a learning path and use a certification as a path to learning, I say go ahead, do it. But if you are doing certification to get jobs, I will say no. That's people's like this companies, this course companies make it so obvious. As good certification, you'll have a very good job. $1 lakh salary, 2 lakh. No, not that's not what actually happened. Because there, I mean, I give interviews to different companies, right? They don't even never ask me about certification. Not like they didn't even care if I put my certification there or not. It's good thing that I have it. I know it's a good credential to have, but companies not even much care about. They simply ask question. They simply ask scenarios. If I can answer them or not, based on that only I get hired, not for any way another, not based on certification. Even salaries also doesn't based on the certification. The companies selling this, telling this you are utter lies. Don't believe them. Even any creator also say do certification to get a job. Okay, that can be they're saying till to get to the gate, like the gate of the gate pass to give it sit for the interview, but that will not give you the job. Certification important for the learning purpose for your own credential. It's, but it will not give you job. It's your skill, your knowledge will bring you the job. So in that point of view, certification important in terms of learning, not in terms of getting the job. Okay, not in terms of getting the actual job. For the get parts, it's okay. Because some, some HR, some companies kind of make it mandatory. You need CK certification. You need AWS AWS DevOps Pro certification. Some set the bar like that. Those cases required. Not all companies done that, but some company does that. So you need to be say that. Okay. Last question from Naga is that how AI like chatbot helps to DevOps professional. Now it's good. Like see, uh, I know many DevOps professional using ChatGPT and similar kind of tools. Like previously, we are supposed to using any unknown problem come to us. We are not antarjamis. We are not born with the knowledge, right? We have to face the problem. Based on the problem that we face, it will be an automatic response to go to Google and search about the problem. We go to Google, we search about Stack Overflow, server fault, whatever it is. We get the some workable solution and then customize to make it or internalize that, right? So, and that's the time taking. Now, with the help of the chat GPT, it's now lot easier, lot less time. We pose the question, it generate the kind of code which help us to reduce the searching time. But it is useful. It's helpful because you don't have so much time to debug and all, because the client and customer always want the solution to be like, they want you 1 minute, which is not practical, but they want you to be doing in 1 minute, right? It's not practical. It may take hours, 1 day, 2 day, 3 day, 5 day. You have to deliver it as soon as possible. Your views on it's on Venkatesh. Your views. Sorry, let me make it big. So your views on premise and Grafana monitoring container. It's no hype actually. It's there from the beginning. It's still there. People who can't afford the paid subscription or paid solution, uh, there'll be problem. But you can more utilize the fluent or fluent those kind of stuff that will much more acceptable, or much more, I would say, more standard. If you use fluentd with the CloudWatch or maybe other tools, that will be better. Okay, Prometheus is good, Grafana is good, but see where you can minimize the cost, where you can minimize the resource consumption, the on all those things. Say Grafana, Prometheus taking more CPU and RAM to run as a daemon. Instead, that what will happen if you run fluentd? Is it reducing the usage? Then it owed that, right? Of course, you consider the cost, you consider every single thing, and then make the final decision. Okay. Okay, so we covered that, and it's already 9:30. So yes, I see many people still. So many people watching. It's kind of very weird, because normal cases, you know what happened? Only 2 3 people stay after this kind of 2 hour session. But I'm very happy to see that so many people watch the entire session. Again, I am not keeping this document to myself. I'll just right now I will release the document into LinkedIn. What I want you guys to share this video with as soon as people as possible, because I am giving it my all. So just as a kind of extending the effort, you all share this video with other people, hoping that they will get the actual knowledge and not some hyped up knowledge which people do, like top hype this top. I don't like that one. Okay, just learn this thing that I've told you. It is not only things, but the most important thing that will help you a job, and help you get a job and help you in your day-to-day life, if you learn all these things that I've talked about. Okay, so again, once again, thanks for staying till now and watching this entire video, Tom, to our video. See you soon in my next video. Okay, and there is next, I was actually planning to do tomorrow one session um, on this, I think, what was the topic, on the containers and virtualization, but something came up. I may not able to do tomorrow, but what I'll do, I'll make a video recording and I will post it. Okay, sorry, I cannot make it live because I have to go. This is the tax month. I have to pay so much taxes. Okay, so see you soon. Next week we'll have the session. Okay, again, thank you everyone. Bye, have a great holiday. Bye. Okay.